Hey everyone, how are you? I'm Torey, Penrod-Cambra, Chief Communications Officer at HighByte, and I'll be your moderator for today's panel discussion. I'm excited to be here today with my colleagues Jeff and Aron for another after-hours session. We're calling this one Design and Query Your UNS, and in full transparency, we already had this webcast this morning and it didn't record. So we are currently back for an encore performance, and I'll let those that attended decide whether take one or take two was better. So let me.
It's like Woodstock 1969. You had to be there, you know, you just had to be there.
Yeah, it's sorry for everyone that's getting the second version in the afternoon. We'll do our best. So let me introduce Jeff and Aron formally. Jeff's a product manager here at HighByte, focused on product positioning, technology partnerships, and reference architectures. He's an experienced technologist who brings more than a decade in technology leadership roles in the automotive and discrete manufacturing industries to his role here at HighByte. And Aron is the Chief Technology Officer, focused on guiding the company's technology and product strategy through R&D, technical evangelism, and supporting customer success. Aron has more than 15 years of experience in industrial technology, and I'm pretty sure I've worked with him for all 15 of those years. So thank you guys so much for doing not one webcast today, but two. I really appreciate it. Next
only
thing I'm going to do.
Torey, only for you.
Let me go ahead and launch into some housekeeping. Ironically, yes, this webcast will be recorded, and I know that because I've checked. It's definitely being recorded now. Slides and images will be available upon request. There was enough requests for them this morning that I think we'll just go ahead and include them in the package you get when the recording goes out. And the Q&A tool is up right now. We'll go ahead and share some poll results from earlier this morning. So you just go ahead and move on. So for the next 55 minutes, we're going to be demonstrating, discussing how to design, query, and govern your UNS with HighByte Intelligence Hub. And you'll see 3 product demos, courtesy of Aron, that really bring this discussion to life. Before we do that, for some of you who've registered for this webinar, you're new to HighByte. So who exactly is HighByte? We're on a mission to provide manufacturers with the critical data infrastructure needed to successfully navigate their digital transformation projects. And we do this through our award-winning industrial DataOps software, HighByte Intelligence Hub. Since founding the company in 2018, our customers now span 18 countries, 20 vertical markets, including life sciences, automotive, pulp and paper, and many more. Fortunate to work with some of the most innovative manufacturers in the world, including Vivix in Brazil. I love this quote so much from Aristoteles. So Aristoteles, if you're watching this recording, thank you for your support and ongoing feedback. So what is the Intelligence Hub exactly? Well, you're going to see it here today, but it's an industrial DataOps application that's built for industrial data deployed at the edge. The Intelligence Hub delivers modeled, ready-to-use data from any asset or system to its destination, using a codeless interface to speed system integration time and accelerate analytics. The Intelligence Hub, you can merge machine, transaction, time series data from a variety of edge data sources into a single payload. You can standardize and contextualize information models in real time. And of course, you can design and project your unified namespace, which is why we're here today. Quickly go through the agenda here. So for the next 50 minutes, we'll be talking about how to design, visualize, and project a namespace to multiple targets to improve UNS governance and usability. We'll talk about mixing machine, MES, and ERP data into a single context. Talk about how to query metadata and values across your namespace hierarchy to simplify pipeline processing. And finally, we'll look at some use cases and see a demonstration of the new native integration with Ignition. So again, I just want to thank everyone for submitting so many questions in advance. We had over 300 people register for this webcast, and we received more than 40 questions in advance, and that truly has shaped this webcast. So I will go ahead and jump right into the first question, which came from Lionel. And I would consider this kind of a best practice question. And Jeff, I'm going to take this one to you. Any recommendations for building MES using HighByte? What are the prerequisites and any idea on how the infrastructure will look?
Great question. Great for starting and level setting the conversation. So as Torey just mentioned, HighByte Intelligence Hub is an industrial DataOps solution. So at a high level, that's middleware, right? It's concerned with moving data, not storing it, not analyzing it, not visualizing it. So by definition, there it kind of infers that that's not an MES, right? But it is often integrating with MES, right? In fact, it's integrating up and down the stack. It's often facilitating MES transactions, and it's often taking MES data and making it more accessible for external consumers. We do have a number of users that are certainly integrating with MES, and I'm going to kind of walk through a couple of different scenarios that I observed that are most common. So the first scenarios I would just kind of call MES transactions. So think common things like recording production, logging asset state changes, maybe capturing inspection records and so forth. A lot of MES systems often have endpoints or some sort of method that requires data that's not just from your automation landscape, but it's often bounded by master data in the MES itself. So you can imagine a scenario whereby a container has been filled or a cycle has been completed, and that event might be driven in your automation landscape. But when it comes time to maybe log that event or complete some sort of transaction in the MES that's related to that, we might need to first connect to an MES, pull down maybe some master data or information or data that is relevant to that particular method or transaction, and that might be merged with the automation data together, and then finally that's all shipped together to complete the transaction. So it's very common that MES is often sort of a multi-step integration. An Intelligence Hub is very conducive to that. The other scenario, which I find quite interesting, observed from a customer in Europe, involved actually label printing. So think zebra printing or those kind of labels that you'll see on the side of inventory containers and inside of a warehouse or a manufacturing plant. This is sort of an interesting one where Intelligence Hub is actually facilitating the transactions between an MES and label printing. What's very interesting about this is that it has a lot of error handling built into it. So if there's a failed label printing transaction, a printer's jammed up, there's a missing ribbon, it's missing paper, they actually have the integration set up to raise a ticket within their IT service management solution to kind of notify people to make sure that that's not a lingering problem and it can be resolved in a prompt manner. The other scenario I'd say is probably the most common is just we'll call it garden variety analytics, where someone might be enriching telemetry data with MES data. So telemetry data is often missing broader operational context. There might be different types of access patterns where you might want to filter data by other sets of operational information. You might want to aggregate data by certain other attributes and such. So being able to blend the data together and land it in an analytical platform has a lot of benefits. The last scenario I will refer to as MES replication. It's simply oftentimes MES is a very local deployed application. It often is very site specific, right? It's generally running directly on the edge, and it needs to be promptly running production and such. It's generally considered sort of a fragile process node in many cases, but there's often a desire to extract that data out and have it available in an enterprise data platform. So a number of our users are extracting data and making sophisticated data pipelines from the MES and consolidating them into a data lake to do enterprise-wide reporting.
Awesome. Thank you, Jeff. Great explanation. I'm going to shoot the next question over to Aron now, which actually came from Lionel too. And I just thought both of these were really good for sort of baseline and level setting with HighByte before we start to get into some more complex demos. So Aron, this one's coming to you. I've connected an OPC-UA server to HighByte, and my goal is to send data modeled from HighByte to OPC-UA. How can I do this?
Yeah, there's no easy way. The quick answer is you have to model the address space of the OPC UA server. So we always say model the destination or where the data is going. So in OPC UA's case, you have to look at the browse space and you kind of have to match that by name. That way you can write into it. Sometimes that's easy if it's fairly standardized. Other times, if it's obscure tag names, you're replicating those. And it's a little painful, but that's the name of the game with UA rights. So no easier way.
Great. Thanks, Aron. Okay, another best practices question. This time I'll come back to you, Jeff. And this is, where is it recommended to store and manage your asset models? You can take this one, Jeff?
Certainly. Yeah, the short answer on this one is really it depends. There's a couple of different patterns that we observed with users. First and foremost, I think it's worthwhile to mention that Intelligence Hub is typically deployed at the edge, and there's a feature called Central Config whereby all the remote hubs can be networked together. The purpose of that is obviously to make those remote hubs accessible and manageable, but it has an interesting features around being able to share configuration, specifically model definitions. So the main, I guess, umbrella terms that we'll sort of refer to model portability is project and container orchestration. So the project, there's a couple of different nuances here. So first and foremost, there's project sync, whereby a user could synchronize model definitions on there. So if everyone was sort of comfortable using the central hub environment, the central hub would be an excellent place to store those model definitions and make them available throughout your data infrastructure. The other approach is we also expose that over the so-called project API. So if you had your own programmatic way that you wanted to manage those models, you could certainly hit an endpoint to manage the model definitions. There's other scenarios where some environments are, let's just say, a little bit more fragile or sensitive and such, and where I've seen environments where the networks are rather air-gapped, so to speak, highly isolated, where shuffling around manual files is often actually a preferable thing for some industries and users. The final approach, and it's probably the most significant or most, I'd say, sophisticated that we're sort of seeing, is for organizations that have kind of dipped their toes into the infrastructure as code world, or they have a formal like DevOps competency in their organization. They're often managing configuration along with the deployment of Intelligence Hub. So Intelligence Hub has a seamless kind of configuration files approach, and that can be embedded as part of the deployment process. So as you're updating Intelligence Hub, you're also updating your model definitions along the way. Something else to mention, just because data governance is often a big thing of interest when people get started, I often say kind of take a pragmatic view of it. Don't let it stall progress. I think by iterating through things and solving problems, you learn more about what you need to effectively address. So I often sort of recommend is start with users or analytics or endpoints, right? And then sort of work your way backwards. By working your way backwards, you'll have a clear idea of what are the ultimate needs, how am I going to create models and such. Because I think sometimes it's a little bit challenging to understand that asset data is kind of inherently chaotic, right? No plant manager is going to say, hey, let's pause production for 5 weeks while we figure out our data strategy. Generally, there's other priorities at place, right? So as a result, you're on some level, you're almost sort of modeling chaos. So I think it's good to kind of start by figuring out what is going to be the end destination or consumption of that data. And then that's going to kind of predicate how you'll model your assets and kind of deal with that chaos going forward.
Perfect. Thank you. Very helpful, Jeff. I'm going to jump into the next question. Now starting to transition, talk a little bit more about Unified Namespace, or UNS specifically. This question, and this will be the last question we do before we move into the first demo. So once a UNS model is designed and in use, how easily can this be adapted to a new situation while not losing the history? This question came from Ton. You can see there's a second part to it as well, too, that goes into more complexity. So Jeff, take this. Will you take this question, please, before we go into the demo on the next question?
Yep. Yeah, this is a great question. I'm going to go through a couple of just a scenario here where I'm going to talk about a pump model and a conveyor model. Attributes, basically, think of those essentially as a data point or an object or a key essentially within the model. And right now you can basically see the instances of the model more or less inherit or reflect the shape of what was defined by the model. Now, let's suppose that presently these conveyors and pumps are just using a standard motor, if you will. There's like a relay or motor starter system on it. And now let's suppose that maybe to save on energy or have more control, these systems are upgraded with a variable frequency drive. And so that obviously entails significantly more data and a lot of interesting, maybe predictive maintenance information that gives us a lot more visibility into the process. So the problem is now is, hey, I already set up these pipelines and I'm already sort of delivering this data here. Do I really want to have to go and update all these different model definitions that I have that happen to have a motor on there? And of course not. Through the process of, I guess we'll call it model composition here, right? I could create a model called VFD, if you will, have the right context, right content in it. But that could be basically a component of both the pump model and the conveyor model. So over time, as maybe another use case arises where maybe there's another data point of interest coming from those VFD models, I can then take that data point, update that single VFD model in one place, and now that's essentially streams all the way through to the model, to the instances of model A. I'm going to go one more further just because I like shameless plugs of new features and such. Here I have the same pump and conveyor model here, but I think the second question had something to do with how do I deal with multiple sort of storage projections, or where am I sending this data to, and how do I kind of keep those in sync as well. So as of version 4.0, we have this new kind of net new feature called namespaces, which is essentially a place to organize data sets or informally model hierarchy right here. And so here you can say I have a kind of a typical asset hierarchy, but if you look at those kind of colors there, and I was too lazy, I didn't feel like actually building payloads, makes it a little bit easier to read here. But you can see those colors more or less mirror the shape, right, of those model definitions there. What's quite nice about this namespace is we didn't just build it for the sake of organizing this, right? We can then project this to different places. So there's a companion feature to this called Smart Query, which is part of pipeline processing, where essentially we can query all this hierarchy. We could query a specific part of it, or we could query all of it in this case. What's quite nice about this is once we sort of project this to things, MQT, there might be a desire to send it to MQT brokers because maybe there's pub sub consumers present, or maybe the access patterns are more conducive to like a data warehouse or a database, or maybe we're doing some sort of machine learning. It makes more sense to maybe land that into a data lake for training and such. What's quite nice here is that essentially semantically we're all consistent, right? Even though those 4 different systems ingest data very differently, they have very different ways of querying and access data, whatever. Semantically, we're sort of consistent here. So now if I was to take this one more notch further, suppose there's another thing that we need to add to that VFD model. From one single place, I can update the definition of that VFD model definition, and all that data is going to seamlessly flow through to all those data consumers or those target systems. So it's a very sort of efficient way of basically modeling your data in one place and projecting it to many consumers without any friction.
Love that, Jeff. It's a great visual too. I think it really like helps take a sort of intangible kind of concept and help everyone understand it. So thank you for that. I'm going to go into the questions, back into questions now. And there were a few questions that came up that had sort of a similar thread to them. So where exactly do I do the mapping of naming standards to one context? Can you demonstrate how we do simple calculations within asset device attributes? How can I contextualize data within the UNS? So when I look across those 3 questions, I think this really gets into how do you mix machine MES and ERP data into a single context? And that question, I think, is probably best answered by Aron using a demo. So sorry, Aron, you got to rest for long enough, but now I need you to jump into product.
Yeah, let's go. Let me know when you can see my screen.
We're good.
These demos went well earlier, so it means something's probably going to blow up, but that's fine. We'll work through it. So let's try. So yeah, so we're going to start with the use case. I'm going to do it a little different here. I'm actually going to just turn on a pipeline that's going to generate the UNS I'm trying to build that has machine data, MES information, and ERP information. So I'm going to show you kind of the end result, the magic trick result, and then I'm going to show you how I built it out. So I'm just going to turn this pipeline on that's going to generate this for me. And then I'm going to launch. I'm just pushing this. I'm projecting this in MQTT. So I'm going to pull up our UNS client so you can see what this looks like. And I guess before I jump into it, this is the factory that I'm trying to emulate, right? So I assume in Portland, Maine here, I have a fertilizer plant. I don't think we actually have any of these. Maybe I'm wrong. Maybe a seafood processing plant. But in this fertilizer plant, assume I have 3 areas: mixing, drying, packaging. I've got a line or some lines in these areas. Drying has 2 lines because that takes the longest. And then there's some machines and assets. So assume that these assets are connected over OPC today. So there's an OPC server that exposes the machine data. Assume in this plant, there's an MES system that's local that we can access information over SQL Server. And then assume the ERP is in the cloud. So we'll say it's SAP, although I did not set up SAP for this demo because that would have been most of my most of my day. So what I've done is I've modeled that right in my UNS, and you can see as you break this down, there's real-time data coming through here. I have my area site line or site area line, and then I've decided in the UNS to put machines, all the machine data under a certain topic. So you can see this is machine data live pouring through. The scheduling data is really my MES information. So you can see this is the work order that's being processed on that line, and the progress and product information. And then the ERP information that I've decided to put in the UNS is really just the customer. Say the operator wants to know, like, who is this work order for? Who are we producing this for today? And that's the same kind of standard across all the lines that I've built. So here's the end result, right? I'm mixing those data sets. So how did I go and do this? So the first thing you have to do is you have to connect to the different sources. So I had mentioned OPC. So I have Kepware running locally. I've created an OPC connection, and I'll kind of cruise through this because this is kind of HighByte 101, but I'm pointing at a tag, and you can see this is the machine data that's coming through. This is pretty well mapped and named, right? That's not standard. I've just done this to make it easy for me, but imagine these are just kind of obscure tag names. Aside from that, I need to connect to the SQL Server that has the MES information. So in here, I've connected to SQL Server running in Docker locally. And actually, if I pull this up just so you can see the schema, I have 2 tables. I have an operations table and a work orders table. Work orders, which you see here, are the current work orders that are being processed 1 through 4 in the factory. And the operations table is the current state of those, where those are. So what area and line is that work order being worked on, and what's kind of the status. So I've created that input, and then under operations, what I'm doing is I'm joining those 2 tables based on the area in the line to get the current state from the MES. So you can see from that join statement, by default, I'm querying mixing line 1. So you see that data gets returned. And there's the MES data. And last is the ERP informations. So I'm going to jump out here. I've created a REST connector. I'm just hosting this locally, but you can imagine this is SAP. I've created an endpoint that you pass a work order ID. I'm just passing work order 1 in as default, and you expand that, and you see this is all the customer information. And this includes who the customer is, purchase info, shipping details, some stuff we don't need in the UNS, right? But that I've connected to all 3 sources. So the next step is I have to model the data. The model that I want to use in the UNS. So I have machine models, MES models, and ERP. I don't necessarily need to model all 3 of these, but I've decided to for this demo. The machine models are just how I represent the crusher, dryer, et cetera machines. So this is modeling in version 4.0. So the UI is a little different, and it's much more enhanced. I won't get into all the details of all the things you can do now, but you can see these are the attributes, data types. You can have hierarchy in models now. You can have composition in models. It's much easier in a single instance that represents that hierarchy and composition. I'm not going to show that here, but that's probably its own webinar to get deep into modeling. But that's my machine model. The MES system, I've decided, hey, I don't want everything that's coming out of that join. So I've created an operations model that just has the work order, start time, so the priority information that I need from that. And last, the ERP information is probably the most restrictive because I don't want billing details and stuff to be published into the UNS. So I'm just doing the customer name, ID, and then the delivery date of the product. So I have the models I want, and now I need to hydrate those into the UNS. So for the machines, what I've done is I've modeled every machine that I showed you in the PowerPoint. So the crusher machine, if you're not familiar with modeling, I've created a crusher. It has a feed rate. So this, I'm sorry, this is the crushing machine. It's based off the crusher model, and this is where I've mapped the actual data from the inputs into the model definition. Little thing that's different in 4.0 is you can have reference types, which are just straight references. And if you've never seen this, you can come in and just kind of drag and drop. So I'm browsing the OPC UA server that's in there, and I can drag and drop these in. These are just straight references, no JavaScript required. One of the questions, you can do more advanced things like mixed signals. So these are two tags that I'm adding together, feed rate and crush rate. It doesn't make a lot of sense, but I'm just using it for this example. But I can write JavaScript in here to have more complex massaging or manipulation of the data. The end result is once I have that modeled up, I can do a test read, and I have, you know, my nice data model defined with data coming from one or many sources that hydrate it, and I'm good there. The only other one I'll show in terms of instances is for the operations for the MES data. I've modeled per section of the plant. I've modeled these, so I have one for drying line 1 operations. So here, this is a new feature in 4.0, the initialization block. So this runs before the instance computes. So what I'm doing here is I'm going and reading that SQL connection with drying in line 1, setting a variable, and then I'm just using that variable as a reference throughout the instance. And the end result is when I do a test read, you know, I get only the data that I cared about modeled according to my data model. The other way to do that real quick from like the 3x way is you can also do that reference in each one of your attributes here. So it's just a different way, but it's the same end result. Okay, cool. So I've modeled my data. I've created instances and done the data mapping, the tag mappings as I need, or the SQL mappings in this case for the MES. Now I want to build my namespace. So this is the new feature Jeff had mentioned in 4.0 called the namespace builder. So in here, the whole point of this is what you see is what you get. So if I go to the UNS client, what you saw here initially, this is basically exactly built out as is in the namespace. So here I've laid out how I'm thinking about the factory at particular nodes that have data. I've linked that. So the crusher, I've linked to the crusher instance. You know, the line 1 in mixing, I've mixed. I've put that under scheduling. Right, I'm mixing my words clearly. Anyway, you can see, so I'm mapping the data into this is basically what I'm doing. And then when this is all ready, I can do a test read, and you see I basically get the UNS in a hierarchy format. So I've built this out. This is sitting now in HighByte. It's how I'm logically thinking of the factory, linked to all the data sources. Now, what can I do with it? That's what I did here to populate it, project it into MQTT. So this is a pipeline. I'm triggering this pipeline currently. There's multiple ways to do it, but once a second, I trigger this. We'll look at the top branch first. What it's doing is it's going and getting the full namespace. This is the smart query stage that Jeff had mentioned. Think of it as the namespace as a JSON document, and this is a query syntax that uses JSONata, which is a syntax for JSON parsing, to either grab the whole thing or parts of it. So I can dynamically query it however I choose. In this case, I'm just going to grab the whole thing. I want the value nodes. I'm going to split it up so each one becomes an event. And then what I'm going to do is just when I send it out over MQTT, I use the path from the namespace, and I'll show you in a second how this works. And then Viola, it's done, right? I get the entire namespace over MQTT with this simple flow. And if I turn on track activity, I'll show you replay just real briefly so you can see how it works under the hood a little bit. So replay just allows me to go through and see one transaction in here. So I ran the query, and what you'll see is what comes out of the query is a series of events. I think it's like 10 or 12. These are all the nodes in the tree that have values. And if you look at any one of these individually, like this one, for example, you can see here's the data, and then here's the metadata, which includes the path. And I'll extend this so you can see it a little better. You know, Portland drying, that's the drummer too. So that we're using this as the topic path in MQTT, and then we're using this as the data. And we could send this anywhere, right? We're choosing to send it via MQTT, but I could send that namespace to Snowflake, you name it. For the customer information, I decided to do it a little differently. This is the ERP information. So I have a second query down here that's grabbing it's using the where clause to say I only want the operations data, stuff modeled off of operations. So I'm only going to grab the MES information. I'm going to do the same thing and break it up. So per line that has the MES information, I'm going to break it up into events. I'm going to grab the work order that's currently on that line, and I'm going to drive the readout to the ERP system with that work order. So I'm using the work order ID and passing it out to the ERP to hydrate that variable. And then I'll condense this so you can see a little better. After that, I model it. We'll get a little bit more into this modeling stage in pipelines, but I'm taking that shape that's coming, the full shape that's coming from the ERP system, and I'm mapping it into the limited data that I want it to show. And then I'm basically just sending that out over MQT the same way. And that's how I'm augmenting with the ERP information. There's multiple ways to do it. This is just another example of doing ETL past the namespace to do the same thing. So that's a lot, but it shows you how to mix the three types of data all in a single UNS, and then in this case, send it out over MQTT.
Aron, that was dense. That was awesome. Yeah, it's exciting to see namespaces and smart query coming together in version 4, and team did such a nice job with those. So slick. This morning, we asked everyone to answer a poll question. And so while the poll isn't live now, I will share the results from this morning. And so we asked everyone, where are you projecting your UNS? Data lake, warehouse, historian, MQTT broker. I'm not using a UNS architectural pattern today, or what's UNS. And these were the results from it. And personally, I wasn't surprised. I think many people are using a broker as the core projection for their UNS. But I don't know, Jeff, Aron, you reaction to these results?
I think it's about what we expected. Data lake, I would say, was higher than maybe anticipated a little bit.
Yeah.
Great. Okay. I'll jump back into questions now. So next up, another question on UNS. And I really like this one from Andrew. While the UNS is revolutionizing the area of automation, do you believe this architecture will be able to scale into different areas of the business? Because having an architecture that's radically different from the rest of the company can have massive costs associated with maintainability and training. And so for this one, Jeff, I'm gonna ask you to respond to this one.
Yeah, another great question. This one I thought was quite interesting, because I think right now UNS a lot is sort of in flux, right? Depending on who you're speaking to, everyone has kind of a different view on things, if you will. And I think on some level we're all kind of collectively figuring out as we go on some level. If you were to ask me in the past, like, would you be comfortable running, let's say, payroll, weekly payroll, and sending it off to your payroll provider, and would you want to relay that through an MQTT broker? I would probably have some pretty major hesitations, right? Or if someone said, I want to do month-end financial consolidation, I want to roll up a bunch of sub-ledgers into a general ledger to do month-end close or whatever, and then do that through MQTT, right? That would sort of be a bit of a challenge. So I guess taking a glass half full sort of perspective here, right? There are going to be some, I guess, sort of like limitations of things, right? Where you probably don't want to do these kind of serious level business transactions that kind of require a lot of, let's just call it transactional integrity, if you will. But where I do say is that there's sort of a pragmatic approach where you could say, hey, you're going to still have these point-to-point connections, or perhaps maybe we're going to look to other technologies going forward, or maybe there's room for technologies to sort of improve. But the other thing you can also think about business data is maybe you're not necessarily using it to directly integrate, but maybe you're just using it to provide visibility. So an example is, instead of someone maybe trying to find out where the shipping table is, or to know what parts have been shipped, what shipments have been shipped today, what trucks are late or such, or maybe what inventory is on hold, right? Maybe it might make sense to have maybe some real-time consumers of these things, where maybe you're consuming them on an event basis, right? So it might make sense to maybe take some business data, and it's not necessarily that you're using it to like fulfill the transactions, but you might be using it to provide visibility on a more real-time basis of some of the business data. I think that's probably the short-term approaches that this could be done. But I think for a while overall, though, I think there's for longer term to have these kind of more broader ambitions. I think there's some room for technology to improve, and our kind of collective understanding on what is UNS and how we can want to kind of facilitate these integrations.
Makes sense, Jeff. Thank you. Along those lines, another question, Aron, I'm coming to you for this. Is the UNS defined in the broker? Is it the single source of truth for the UNS?
I think I'll make the same joke. On the webinar, I said UNS is like consciousness. The more you try to define it, the more it eludes you. And I think there's some truth to that. There's a lot of debate on what UNS is. I personally don't think so, right? I think it doesn't deter from the fact that MQTT is immensely useful for report by exception, machine data, and integration. But to me, UNS is currently, it might change, is logically how you think of your factory or your process and how that's linked to the actual data sources that drive it. And then you can take that definition and project it into different technologies, MQTT being one of the really useful ones, but like we saw, data lake, historian. Yep. So I see it more conceptually like that versus a thing like a broker.
Great. And so profoundly deep as well. Thank you, Aron.
Yep.
Metaphysical response. Okay, another question on UNS. So this one came from Jordy. Thank you for submitting this one. How could UNS be linked with data governance, i.e. data catalog, product glossary, etc.? Jeff, you take this one.
Well, this one gave me the stream of consciousness. Let me fire this up. So you can obviously see all the text there, whatever. That was just, man, I thought it was a great question on there. And I was thinking about it from many different angles, but really what it boiled down to was kind of two things. There's data in motion, and there's data at rest. Mm-hmm. If you think about data at rest, in generally, let's just be honest, most data at rest in kind of a business context has historically been relational databases, right? And those kind of have had like a 50-year head start. So they're kind of mature both in the industrial and non-industrial world. If you look at a lot of the tooling in that space for data governance and sort of cataloging, a lot of it is kind of predicated around, you have these systems and tools that kind of monitor or kind of profile data that's either been ingested or has been already persisted, if you will. But it's also generally used to solve very specific problems that maybe I don't know are as relevant maybe strictly within industrial data. So for example, like, some localities have strict privacy regulations, right? And so a lot of these tools are often sort of used as an enforcement or a compliance tool to kind of make sure, hey, I'm not exposing personal data, or it's only exposed to the right people and such. It's a protected column, if you will, in a database. The other scenario that also I think comes up is that a lot of business data can be inherently human driven, if you will. So think about it as just like forms in a CRM, or it could even be customer facing things. A lot of times those forms are sort of malformed. So maybe they're not well typed. People aren't punching in dates or numbers correctly. Maybe they're spaces instead of dashes or something like that. So some of those tools are sort of solving that. And then the other aspect is that a lot of times there's just like a lot of legacy systems that you're kind of effectively replicating data or doing ETL from, and they're sort of used to solve that problem. When you go and pivot to the industrial world, there's some sort of inherent problems, right? The data is generally not as discoverable. If you think about like how a lot of device data is, you often have to kind of punch in some sort of register address before you get data. So it's kind of this like really intentional process. It's not like, hey, I'm just going to start mindlessly replicating data, if you will, right? So what you choose to acquire is generally sort of deliberate. Again, here's sort of another theme is that, this raises questions over maybe some potential limitations of MQTT, right? It's not there isn't native browsing to it, right? So how would this kind of approach work all that well? But there's another kind of consideration to sort of think is that when you have UNS and when you have DataOps as a strategy, on some level, maybe you're kind of solving the I'll call it the garbage in, garbage out problem. Industrial like process control nodes are going to kind of inherently be stable. It's like you buy an asset, you're not programming the software, the machine is not being updated on a frequent basis. So as a result, maybe you're not having that much variability in the data. So you could argue though is that with the power of sort of DataOps, where you're acquiring the data and you're sort of modeling it, and it's going to that UNS, it's always consistent and nice. You could arguably that when it comes time to project that namespace, let's say to your enterprise data warehouse, let's say Snowflake, you could argue that the whole data governance or data catalog kind of objective maybe gets a little bit easier, right? Because you're doing some degree of almost, we'll call it pre or micro governance, if you will. And because I'm always happy to shamelessly plug features, one thing I wanted to kind of mention on is Aron just kind of showed a demo earlier where he kind of did so-called tag mapping, right? And this is what I refer to as explicit mapping, right? Taking lots of different data points and mapping them into a structure, if you will. In 4.0, we did add a new capability, which is referred to as pipeline modeling, but I kind of refer to as a implicit modeling paradigm. So instead of maybe having to go through every single data point in your factory and explicitly, mapping them into a data structure to make sure that like, hey, I'm always publishing the correct shape the correct model definition is always going to the destination. This kind of allows you to almost have a bit of a model by exception approach. But I think it's really well conducive to this kind of data cataloging or data governance approach, where maybe you're already working with pre-structured data, but what you're doing is you're basically saying, hey, does this thing that's already kind of shaped meet the definition of what I've defined? If not, I can reshape it. If it does meet it, I can sort of pass it along. So overall, I kind of think this is overall sort of conducive. That kind of maybe makes the whole idea of at least data at rest governance sort of feasible for now and a lot easier. But I think the data at motion thing, maybe the jury's still a little bit out. The data streaming is kind of a newer thing in our, and what I mean by new is it's probably like 20 years old, if you will, which basically means in the industrial world it's about brand new. So so yeah, things are a little bit complicated, but it's exciting though. We're all kind of thinking about interesting things and how things evolve.
Awesome. Thank you, Jeff. I am going to pull back up the next question, and fair warning, Aron, it's coming back to you. So I think these two are best answered with a demo. And the first question then is, in context to industrial automation environments, please share your experiences between generalized versus specific data structures and relationships. And then the second question, how do you transfer this into the data lake? And so, Aron, I'll turn it over to you.
All right. Let me know when you can see.
See you.
We're good.
Sharing. All right, cool. Yeah, so this is the question. There's really two types of modeling is what this gets to. There's asset-based modeling where, and then there's use case-based modeling. We do both, right? But we really try to focus data ops, industrial data ops on use case-based modeling. But asset-based modeling helps you achieve, replicate use cases faster. So what do I mean by that? Asset-based modeling is kind of what I showed you in a little bit, mostly what I showed you in namespaces. So to frame this, let me just import a new namespace that I have. Let's go choose the file. So I'm going to bring this in, and it's pretty much a copy of what I kind of already showed you. It just removes the MES information. So I'm just strictly modeling the machines in this case. And I'm just calling my machine example. So let's assume that I've modeled the machines. Now we get a lot of questions about asset-based modeling and trying to synchronize these definitions across all of your factories. And how do you do that? Synchronization problems are hard. And it's a worthwhile goal to achieve like asset model synchronization, but it's not required for use-based modeling. And what I mean by that is, in my opinion, in the long term, asset-based modeling gets pushed all the way down to the PLC or devices, right? Devices at some point, and Jeff made the joke 20 years is new. So like, who knows when this is going to happen, but at some point assets are going to come online on the network and be totally contextualized and tell you exactly what they are. It's not going to be a flat list of tags that you have to go figure out, but there's going to be enough there that you don't need the controls engineer to tell you like what this thing about looks like. That's not where we're at today. So you need to do that asset modeling at some layer. You can do that in HighByte. We help a lot of customers do that. Here's an example of that, right? Built into the namespace. You can also do it in other products like Ignition, like Pi, and others that do this. Okay, so that's asset-based modeling. What do I mean by use case-based modeling? So use case-based modeling, I'll give you two examples. Let's say we already have the asset model. We've done it in HighByte, and then in the near future, I'll show you one in Ignition. But I'll go into use cases, and there's two use cases I want to enable. The first one is an energy-based use case. So I've defined a data model for that captures the machine status, the power the machine is using currently, ambient temperature, and location. So think of this as there's some cloud service that's going to monitor our power usage, and it needs this data. This is pretty simple. It might be more complex in real life, but the use case is we're trying to monitor the power usage of the machine based on status. And what we're going to try to do is figure out if and when we should shut machines down based on like peak power hours where power costs a lot of money, right? So we're going to try this use case. The other one, use case driven, is motors. So we have a bunch of motors in the factory, different types that are on the machinery. And what we want to do is use vibrations. So I have fast Fourier transform stuff here, RPMs and power consumption to try to predict motor failures. This is more of a predictive maintenance use case. And we might have to augment the machines with sensors, but anyway, the end application in the cloud that's going to be shared across all your factories, this is the data model that is required to enable them in this use case. So let's look at how we would enable this on top of the asset model that we've already created. So to do that, I'm going to go into my example use cases. We'll start with the energy one. So this pipeline is going to wake up every 10 seconds. It's going to use Smart Query to go into that machine example namespace. We'll just pull this over and refresh. So you can see that again. So I'm going to query this part of the tree, and I basically want all the machines that are in here, with the exception of I don't want motors. So in the next use case, you'll see what I did with motors, but I added this into the namespace. So this is saying, give me everything in there, but exclude motors. I want the value. Like before, I'm going to break it up and send out individual events. In those events, what I'm going to do is I'm going to adhere to my energy monitoring model. So I've selected that model. Like Jeff had mentioned, what I can do now is, because I've modeled my assets inside my factory, I've made it really easy to map that out into this use case based data model. Now, if some other factory doesn't have this, or some other factory modeled their assets different, that's fine. That's internal to the factory. I don't care, but I can still come in and browse and easily do this mapping to my use case model if they've already provided some context in the factory. So I'm not doing raw OPC tag mappings, for example, at that point. So here you can see I've mapped this in. So I adhere to the data model, and then I'm going to send it out to Snowflake. So if I turn this on, I go jump into Snowflake, and I have some example data. I was running this earlier in the first demo, but it's going equally as well. You can see that if I sorted
Don't
this,
jinx yourself, okay?
Machine status. I've published this in Snowflake, and let's assume the application is in Snowflake, or there's some application that can pull this data and run on the use case, right? So that's a use case based example. The other one I'll do is the motors, and this one's a little different because let's assume that the motors aren't part of the traditional asset model. So it's not data that's coming from the OPC server. Let's assume that we retrofitted these machines with some vibration sensors that talk MQTT or something like that. So what I've done is I've actually created an instance of the motor. If I go into use cases here, because I need to map this to data sources. And in this case, I've cheated. I'm just doing random number generation. But you can imagine if there's an MQTT source or a REST source, Modbus, or wherever this information was coming from, we could link that in. And then what I've done in the namespace is I've said, well, some machines have motors and some don't. So like drying, for example, has no motors in it. The drum dryer has none. The granulator has one. So in the pipeline for the motor use case, what I'm doing is once a second I wake up, call the namespace. So I'm running the smart query. In this case, I want only the motor stuff. That's the only stuff I'm going to pull. And then I'm going to buffer that for 20 seconds. I'm going to turn that into a CSV format because that's what the end application needs. And I'm going to send it up to Azure Blob. Like that's the integration point. And if I turn this on, we won't have to wait those 20 seconds because I have some, again, from the first demo, some examples up there. You can see here's the data that's landed up here. If Azure Blob wakes up, and if I download one of these files, it's the CSV format that you would expect. Let's go open it up quick just so you can see in the data in the data format that we described in the use case. My machine seems to be running a little slow, so it's taking some time. But you can see there's the data model. The point is that I can quickly enable this because I have an asset model in my factory and I provided some of that contextualization, but it's not important necessarily that I share that asset model across my entire enterprise. What's important is I share these model definitions, like the energy use case, because that's the one that has the common resource. Everyone needs to push up to the cloud in the same format, and I need that abstraction. But I think it's important to understand those two different types of modeling and why it's really important globally to standardize the use case ones. But the asset ones over time, standardizing is great, but it's not required out of the gate. And I'll send it back.
Really good explanation, really good demo. I'm impressed. You pulled that off now twice today, so that's pretty good. Right? I'm going to share results from a poll question we asked earlier today. Do you use Ignition by Inductive? And I thought these results were interesting because it so mirrors what we see as well. I think I asked Jeff this morning, from my recollection, I was thinking, I think it's about half of our customers also have Inductive in their reference architecture with HighByte Intelligence Hub. And that's about what we're seeing here too. So just really interesting to have that stat reflected back to us. And I'll share one more thing right now, which is also in the live edition earlier today. I asked a question that came in from one of the registrants from Steve, which was, what is Jeff's favorite Korean entree? And Jeff gave a response to that, but you had to be there. So if you want to hear the answer to that question, you're going to have to schedule a disco with a sales development rep, and they'll give you the inside scoop on Jeff's Korean food preferences. So sorry if you missed the live version this morning, but you're gonna have to work a little harder to find that answer out.
I
Okay.
remember what he said, but I don't remember I don't know what it is. I'm so like, I just don't know any of that stuff.
I don't remember either.
It's like,
Don't botch it,
it was
Aron.
noise. It was noise to me.
Yep.
All right. So so obviously the poll question came up with Ignition in the final stage. So I'm going to ask this question to Jeff, and then we're going to wrap up with one more demo from Aron, and then we'll wrap this up. So this question, Jeff, Ignition. I love this question from Ryan C. It's a tough question, and we did not shy away from it, which is, what is the difference between building the UNS and HighByte over Ignition, as it seems like another tool to do the same thing? So Jeff, respond to this one.
Excellent. Let's go through a journey. So we have a journey of a lot of our customers. So we have some pretty very large customers that have over hundreds of sites, right? With many Ignition gateways around there. And I want to kind of walk through sort of a journey of what we've sort of seen as organizations kind of develop their kind of digital maturity, or they find what works and doesn't work, right? And how this kind of rolls into a broader data strategy. So the first thing is obviously Ignition has this incredible licensing approach, right? The kind of unlimited everything, if you will, right? There's no restriction by tag counts and all that type of thing, and that works really well. And it has a lot of different modules and sort of functionality. What we generally observe over time is that Ignition is actually not just one thing; it's actually kind of many different things. And there's kind of a couple of different sort of main categories that we see people tend to break out their gateways, and they tend to deploy them for different functional purposes. So sometimes Ignition's a SCADA, and sometimes it's not, because believe it or not all manufacturers necessarily need SCADA, if you will. Sometimes it's an MES. Some people are using the Sepasoft modules. Some people are even building their own on top of the solution. Other times it's a local HMI solution. And then there's other people that are just sort of using it as an IoT platform. The Perspective module's like incredible. It's probably one of the best visualization solutions on the market, and people build incredible apps with it, right? So now we'll kind of evolve what this sort of looks like as we start adding different dimensions, meaning more sites, more users involved, more use cases and such. And here's kind of how things sort of evolve. So when it comes time to start kind of integrating these things, we might first start with like kind of the telemetry area, right? And I think Aron brought up an interesting point earlier about kind of asset modeling, right? It's sort of inherently chaotic, right? When people stand up SCADAs or sort of HMIs, they're generally, it's a very bottoms up approach. That is, it's designed to, if you're building a UDT to say control a pump or a motor or something like that, it's going to be to solve that need for production, right? It's not, again, going to be because we're going to put production on hold for 5 weeks while we figure out our data strategy, right? So inherently, there's a tendency for those things to drift over time. And it's not a reflection on Ignition as a platform or anything like that. It's just the inherent nature of process control data, meaning that sort of assets are kind of inherently heterogeneous and chaotic, if you will. So quickly there becomes a need for kind of that data engineering capability, because if you want to enable those sort of like use case based modeling approach, right, you kind of need a way to sort of remediate that variability happening in your telemetry landscape. The next area is as people start using Perspective more and more, they're going to want more and more sophisticated data pipelines sort of feeding into there, or they want more sophisticated data extraction. They want to project things into there for a variety of reasons. And then obviously there's the MES factor, right? You could be using the Sepasoft stuff, but you might even have other applications in place. And so there's a strategy that there's a question that kind of comes to place is I have business analyst users that are maybe not necessarily industrial controls engineers, right? Maybe they're not used to writing Python scripts and such, right? Maybe they're accustomed to other types of tools, if you will. Or maybe there's a need for things like change data capture. We have a number of customers using sophisticated database extraction techniques to essentially replicate MES data out of Ignition. The other scenario that we'll also sometimes see is people might go best of breed with device data acquisition or other types of data sources, right? Mm-hmm. They might want to templatize or dynamically address things. We're starting to even see more sophisticated DCS and PLCs where they kind of have the native alarming and they're exposed over OPC way alarms and conditions, we're starting to see much more sophisticated interfaces and such, where people might want to say, hey, I'm not going to bury this thing behind a gateway. I actually want this to be kind of like a first-class citizen in my architecture, if you will. The other scenario is time series. We have a number of users that are using Pi, for example, where they might want to say, I need a strategy to both replicate my Ignition tag providers, the hierarchy in there, with my asset framework hierarchy, right? And so there's this whole broader strategy of how do I acquire data? How do I project data into those systems? How do I backfill data and so forth? But keep going, there's another area is files. Files is a huge thing. People get very opinionated about protocols, if you will, but you often hear from a lot of real world users and they're saying, yeah, I'm just lucky if it produces a text file somewhere. And that's kind of a nightmare to acquire data and so forth. So that's another area that's almost kind of like a dark spot, or there's another need for further data engineering. But the story goes on, whether it's going to cloud systems, event services and so forth, even targeting storage layers and such. So when you kind of take a step back here, obviously there's a lot of different kind of demands for data engineering, right? A lot of different people start needing to sort of be involved, and then there becomes a clear need to say, we have to have a data strategy. How are we going to sort of address this? And this is why like a lot of Intelligence Hub users also have Ignition in their architecture because they're so complementary. In 4.0, we released a native integration by basically developing a module that is deployed inside of Ignition gateways. That gives us access to effectively all the core APIs. So that what that allows us to essentially do is go beyond basic read and writes with sort of standard protocols. We're also able to sort of create schema, read structured data and such. And so when you think about some of the other native integrations that we've had to Pi or the clouds or a lot of the cloud services, it seems like almost every release we're always tweaking that because there's always great ideas from users as times go on. So what I'm very excited about this is not just about the functionality that's sort of available on day one here, but kind of what this entails for the future. There's going to be lots of sort of interesting things that come up in place, and people will have really sophisticated and exciting integrations going forward. I'll pass it on to Aron.
It's awesome. Great, thoughtful.
Oh, Jeff, you can't do. Only Torey can pass it to me.
Oh, sorry.
Thank you.
Sorry, I've always done like the webinar ending at a specific time.
You know the rules.
Torey, we're cutting you out. You're out of here.
Yeah, there's not like 2 minus 5.
Show now. No, we need you. We need you. Please.
The wheels are coming off the bus, guys. Last question. Stick with me.
Just hit
hopefully
it's
recorded this time.
Okay, so last one. This is it. Jeff just like set that up with context so well, and so now this is perfect, honestly, for Aron to demonstrate it in a product. And so this question came in from Kaj: how to best integrate machine SPS or PLC data into the UNS directly via the SCADA system or both ways. So Aron.
Yeah, let's take it home. Let me know when you can see. I think that the quick answer is depends. The easiest way, right? Pick the easiest path. So if there's a SCADA there that has it, which I'll show with Ignition, that's oftentimes the best way. So as Jeff mentioned, we created an Ignition connector. There's a YouTube video on kind of explaining in the beta, why we did that. The main reason is to get access to user-defined types and the rich context that's in Ignition, both to move that data into Ignition and pull that data out. And not require Sparkplug B and MQTT to do it necessarily, although that has a valid use case, but we don't think you should have to adopt it by default. So just as an example, on the install, so you go to config modules, this is the Ignition UI. From our website, you can download our module, and I've installed that here. So this is kind of how it shows up. And then on the left here, you have the settings, which are pretty minimal. Just is it on or off? What port is it listening on? And then the password or credentials that you'd use to connect. So on the HighByte side, once that's set up, it shows up as a connection in HighByte. And in this example, what I'm going to do is let's assume there's another factory in Albany, New York, that's also a fertilizer plant, and it uses Ignition. So the fertilizer factory that was that we previously showed that was using OPC and the local MES, this is another factory doing the same thing, but it has a different tech stack, which is pretty common. So this one's Ignition. So I've connected. I've got the port and IP, and once I'm connected, like other connectors, you can browse. I can see all of the tag providers, and we'll get into the inputs and output stuff in a minute. So let's assume two use cases or two scenarios. First, the factory has Ignition, but they're not really leveraging it with connectivity to the namespace. So they've done some local stuff like IoT platform stuff or perspective screens like Jeff had mentioned, but we've actually started to build that namespace out in HighByte, and we want to get that into Ignition because it's advantageous to have access to that data. And we might, and we can extend it once it's in Ignition. So what I'm going to do is I'm going to create a data flow. If we jump out in the Ignition folder, that's going to take, I already got this one on, so I'm going to shut this off. Let's go back. So this one's going to take the namespace that we've defined in HighByte, and it's going to move it into Ignition. It's really simple, right? Once a second, it's going to wake up. It's going to go grab the Portland namespace. It's a little, this is the power of Smart Query and JSONata. The syntax is a little weird. It's a JSONata syntax. But what I'm essentially doing is I'm saying, hey, in this namespace, only go grab things under machines, right? Which kind of shows you the flexibility here. But that's what the syntax is doing. And I want the name model and value. And when I turn this on, then I'm just going to write out to Ignition. I'm going to turn on the create option. So we'll create everything if it's not there. We're going to land under the fertilizer demo tag provider. So if we turn that on, no errors, looks good. We jump into the Ignition Designer and refresh. We'll see there's a fertilizer demo, and pretty cool, right? Like that namespace shows up exactly as we defined it. What you see is what you get, like we did over MQTT. We did the same thing direct into Ignition. And the UDTs, right, are defined. So these are coming from the models that are in HighByte. And if you extended these, you'd see that there's the model definitions. And then the instances of those UDTs are actually defined, and the data is in there. So we're taking that and replicating it into Ignition. And now this is available in Perspective and all the other tools for Ignition to use. So that's pretty cool. The next use case, I'll just keep that one running. The other one is the scenario where, well, Ignition, someone's developed some UDTs and some structure in Ignition that it's already there, right? So we don't need to recreate that asset model in HighByte. Ignition already has it, but let's take the energy use case that we looked at earlier and let's enable it on top of that asset model. So what I have here is a flow or pipeline, sorry, that is going to go read Ignition. And I set up an Ignition input that just reads the fertilizer demo Portland branch. And if you read that, you'll see I get all the data that's in there, as you'd expect. And then this pipeline's a little different. What it's going to do is I have a little bit of JavaScript here, and this comes from the user guide that's going to let me go through the payload we just saw and grab the modeled stuff and turn it into events. This is essentially what Smart Query is doing for you when you query the namespace, but you can do the same thing in JavaScript. I think over time, we're going to look at extending Smart Query into actual connections and inputs that could intelligently respond to smart queries like OSIsoft and Ignition and some others. But for now, a little bit of JavaScript gets you the same place. So once that's queried, what I added, and I haven't shown this yet, this is a model validation stage. So let's assume I got this pipeline, this energy use case pipeline from the Albany plant using Ignition working. And I want to make sure if someone, like Jeff had mentioned, if someone goes in and adds some tags to these data models or modifies them because they want to enhance the screens, it doesn't mess up this data flow and end up landing junk data in my data lake. So this model validation stage is saying, hey, whatever events come through here have to abide by these data models I've defined, at least one of them. And if it doesn't, I'm going to take the failure path, and then we could log that to a database, or we could have some process by which someone would go in and fix those bad data points. But it allows us to maintain our standardization of the data lake and not push junk data there. So once it's past model validation, now I want to enable the energy use case. So like you saw before on the namespace in Portland, this is just going to take the data coming straight out of Ignition, and it's going to map it into the energy use case model, and then it's going to end up sending it to Snowflake to the same table that the Portland location was. And that simply, once I turn this on, I think there were some in there already. Snowflake, you'll see a mix of the Portland and the Albany data. And Snowflake's running slow at the moment too for me. But there we go. There's some of the Albany ones. And obviously I'm missing some data points in here in the mapping, so I'd have to go back and fix that. But it's an example of I can quickly enable the use case on top of the Ignition system, and I don't have to replicate all the asset modeling. Ignition's already done it, so I might as well leverage that.
Awesome.
And that's a wrap for me.
Aron, so good. That means you did, I guess, six demos today. So that's like a record.
That's it for the month. I'm off till December. Yeah.
For everyone that attended this morning and saw the live version, I'll let you vote on whether the take one or take two were better performances. But seriously, though, thank you to Jeff and Aron taking the time for doing this, and especially for recording this. I think it's really helpful information for everyone that's like either new to HighByte or a super user. So thank you so much sincerely for doing this again, and I owe you one. And then for everyone that attended this morning, thank you. For everyone watching this recording, thank you as well. You can always visit highbyte.com to get in touch with us or to see additional resources. And we will be sending out this recording within the next 24 hours, as well as some additional resources. So thank you again, and we'll see you soon.
Cheers.
Bye, guys.